Thank you for attending my session on recruitment and retention of female students through project-based engineering camps. My name is Lynford Goddard. I'm a professor of electrical and computer engineering at the University of Illinois. I'll be talking about the Girls' Adventures in Math, Engineering, and Science summer camps. Since its inception in 1998, over 4,000 girls, approximately 800 of whom are African American or Hispanic Latino, have explored STEM fields through demos, classroom presentations, tours, and hands-on activities, and have made contacts with female university students and professional engineers. Games Camp offers 8 different tracks in engineering, spanning electrical and computer engineering, chemical engineering, aerospace, computer science, material science, mechanical, and environmental engineering and bioengineering. In fall 2015, 16, and 17, a total of 73 past Games campers out of the approximately 500 who attended enrolled in our College of Engineering. And so this is a really great indicator that our camps have been effective. Additional girls, or the other girls, probably attended other universities. The Games Camp is not only a successful recruitment program, but it also helps to retain women engineering students across the college because they get to act as counselors and instructors. They reinforce their learning for our love of engineering. Here are some pictures from the Girls Learning Electrical Engineering Camp. So I'll talk specifically about this camp because this is the camp that I organized. Over 180 girls have participated since 2010. A typical week, participants will explore the subfields of electrical and computer engineering through hands-on demos and activities, tours of research labs, and also projects. So in this upper corner, they're building a FM transmitter circuit and verifying it. They're touring a research lab. They're going in the clean room and fabricating solar cells, and they're working on digital logic with an LED calculator. In a typical week, on Monday, we do an introduction to circuits. They have their own digital multimeters, and they're able to measure Ohm's law and to understand the basics in electronics. We use the oscilloscope in our undergraduate teaching lab, and so the high school girls are able to use state-of-the-art equipment. We do radiophone prototyping on a breadboard in the freshman lab. We tour on the second day. So the second day we tour some of the research labs. So we visit Jen Bernhardt's anechoic chamber for testing RF radio frequency transmitters like antennas and so forth. We do soldering. So the girls learn how to solder and they build their FM transmitter circuit. They learn circuit schematics and how to do soldering properly. They continue with the soldering, and then they build this final circuit which can transmit their voice as an FM radio signal. So this is a really great project where they get to learn about circuits, but they also get to build something fun. They then go outside, or they test it inside, and they pick up their signal on a FM receiver. We then go and we tour other research labs. So this is Grace Gow's drone lab. So the students are able to learn about the activities in drones. We tour my lab, so I do optics and photonics, and so this is my graduate assistant, Lana Edwards, with the students, and she's explaining her research. We do LED calculator design, so we learn about simulation, and we learn about how to build circuits. We also have them tour the clean room, and they actually use the equipment to fabricate their own solar cells, so this is them fabricating the spin-on dopant on a silicon wafer. And they love to be dressed up in these bunny suits and see what it's like to be an engineer. They also build the LED calculator. So this is a digital circuit that uses logic gates on the breadboard. They get to troubleshoot as teams, and they work on this together. They also build this optical imaging projector. So using flashlights and cutout paper, it can project images. And then on the last day, they learn about algorithms through this card sorting game that I've developed. They do controls lab and learn about segues. They do PID control loops, so they control the speed of a spinning motor with LabVIEW. They have lectures by instructors on nanotechnology. And then they build their solar cells in the afternoon and they test it outside. And there's also time for them to spend just bonding and doing fun stuff on their own. So this is a great opportunity for students to really bond and make connections. So this camp has been extremely successful in providing hands-on exposure. In recent years, we've translated the model to other initiatives, so shown here. And then currently, I'm the director of the IDEA Institute. So this is an institute on inclusion, diversity, equity, and access. and we have an open position that we're interested in filling. Thank you.